Okay, I would really have loved to make this a live session. Okay, so can you guys hear me better now? I made a few changes to the entire. Oh, beautiful. Okay, so apparently I was the one who was causing all of these problems initially. Thank God we have a better stream session now. Okay, good. Thank you everyone for sticking around. My apologies for the hiccups here and there, but I'm glad we have this working now. Okay, so like I said earlier, so that means I'm going to have to do a bit of reintroduction and going back on this. Okay, thank you very much. So first of all, my name is Adetayo Kolade. For those who are probably just listening to this for the first time, I started that channel Data Analytics Africa on Telegram on that group because I want to, you know, share my knowledge on data analytics and have us all, benefit from some of the things that you probably won't get from regular trainers, but you would, I'll be able to impart that knowledge here. So I'm a data analyst, data scientist. I work with IHS Towers. I I do a lot of data wrangling and data management and data analytics, and I'm glad to be able to share this knowledge with you. So the very first, let's just dive right into it. I think we've wasted a lot of time trying to get this right. And so first of all, from the Telegram channel, I said something earlier before we started this. I said I was going to do a review of the assessment I shared, which I expected everyone to have participated in. Thank you to those who were diligent students enough to do the assessments, and to the rest who probably didn't do. In fact, and I think for most of the people here, they are the ones who actually took the assessment serious, and I appreciate everyone who did. I am using assessments as a way to get or demand accountability from all of us. The reason why I am sharing assessments, or what I want us to go through assessments, is because I feel that with assessments, people will be able to take these classes more serious, and I'm glad that for those who have done so. Now let's dive right into it. Let me bring to speed, or let me bring to the page the assessment results. So you can see the basic responses and how people have answered so far. I'm sure everyone here basically read through the materials I shared, and they took this assessment. For those who did not and just came in and did guesswork, clap for yourselves. For those who actually did, well, read through and got up with the answers to this test, yeah, thank you very much. Surprisingly, I think the first question, which I thought was going to be a very, very, very simple one person missed it and wrote structured command language. It's a bit surprising that the person didn't even choose strict query language, because that's like closer to SQL than SCL, which is structured command language. Anyways, so SQL stands for structured query language. Please don't confuse me. Structured query language, which is a sequential language used for querying databases or relational database management systems. Okay, so the answer to that is structured query language. That's a bit straightforward. What is the term used for the unique identifier of an entity? Okay, most people got the answer correct, 81.4% at primary key. That is the unique identifier of an entity. That's the primary key is unique throughout your records in a database. You don't have one primary key repeated in your entries on a database. Okay. Next question: which of the following are true? So the answer to this is the fact that, sorry, hold on, let me go through the answers again. You can have two columns with the same name in a table. You can have two columns with the same name in a database. Okay, both of the above. So apparently you cannot have two columns with the same name in a table. Each column in a table is a unique attribute, okay? And because you are going to most likely make reference to your records based on, sorry, let me go back to my, okay. So because you can you can make reference to the contents of a column based on the name of that column, it is technically impossible for you to have two columns with the same name in a table. However, you can have two columns with the same name in a database, but that means they will be in two different tables. So you can have table A with a column name called employee ID. At the same time, you can have table B with a column name named employee ID. Because they are in two separate tables, they are two unique or two standalone columns in two different tables with the same name, quite all right, but not in the same table. So you cannot have two columns with the same name in a table, but you can have two columns with the same name in a database. So that's the correct answer for this. 40% of our respondents got this correctly. Okay. The next question: how is data stored in a relational database management system? Yeah, that's the correct answer. 95.8% of people got this correctly. Thank you very much. In tables consisting rows and columns. Okay. So that is the correct answer for that. In your relational database management system, you have, like we said earlier, in an RDBMS, it consists of multiple tables, right? And those tables consist of rows and columns, and each of those rows and columns are what form the basis for your table. So that's the correct answer. In tables consisting rows and columns. Keys and columns is not correct. Tables consisting of tuples only is not correct. A tuple is a row. I'm sure for those who read through, I'm sure you got that right. Now for the next question, which of the following is not an example of a relational database management system? Surprisingly, some people picked none of the above. Okay. MySQL is obviously a relational database management system. SQL Server is a relational database management system. Oracle database is actually the most popular database in enterprise systems. IBM Domino, on the other hand, is not a relational database management system. In fact, IBM Domino is another type of database that uses NoSQL. We are not talking about that now, but I will go back to that later. So, next question says, primary key should be chosen. Please, if at any point you are confused by what I am saying or you have objections or questions, please just drop your questions in the comments box, please. That would do very well for me. So, question 6, primary key should be chosen such that its attribute values are, well, a primary key is never changed. That's the only unique thing that identifies each of your entries in your database table. Okay. I'm sure some of the things I'm bringing up here we will discuss better when I go through the PowerPoint slides. Okay. In a relational model, column of table is known to be, well, 60.6% of people got this right. It's an attribute. Each column in your database table is an attribute that identifies the entry or the record you have in that table. And to the last question, in relational model, row of table is known to be, well, a row of a table is known to be a record or a tuple. A tuple is a mathematical term for a collection of data sets or data entries. All right, this is the end of this review. So we're going to be able to talk better about this review when I start putting you through the contents of the PowerPoint slides I created. There's one thing I think I missed out on that PowerPoint slides though, and I'm going to try and create an alternative to that and share with you also, which is actually data. Let me just update that now, data types. Okay, so let me bring to you let's move straight to today's class. Right, so thank you everybody so far. I think I've been able to, yes, I will share the PowerPoint slides so that everybody can, I'm going to make a few additions because I think I tried to rush this up because I was very busy yesterday. Today also was a very busy day at work, but I was able to come up with something. Going forward, I'm going to work on something better and I'll share with you, okay? I'm going to make a few additions to this PowerPoint slide and I'm going to share it with you at the end of this session. But for now, this is just a basic and very quick one for us to go through with. So like I said earlier, the purpose and the primary reason why I think I came up with this initiative is to change the concept, the misconception, or change the narrative a little bit. A lot of hold on, class. Okay, so sorry for the brief break in transmission. So like I was saying, there are a lot of people that go into data analytics classes without a basic understanding of the fundamentals of data analytics. As a data analyst, you're primarily analyzing data from your enterprise or from your organization, and you are using that data to make informed decisions for your organization, right? In most organizations, in most large enterprises, nobody stores their data in Excel files anymore. Prior to now, everybody had, I'm sure most small companies have their data stored in a small Excel file. Most small organizations have the bulk of their data stored in just an Excel file. And but because an Excel file has its own limitations, right? You're limited to 1 million rows of data. You cannot perform some maybe advanced analytics with an Excel file, and the memory crashes that an Excel file will limit you to. It means that for an organization that has data exceeding 2 million, 3 million rows, or 5 billion rows, for example, imagine an organization like Google that takes in data entries from different sources. You have your mobile phone sends data to Google on a daily basis. Imagine 1 billion Android users pushing in data to Google servers every 5 minutes or every 10 seconds. It means that you are having a very large explosion of data. At 6 billion rows of data entered into a system per minute or per hour, it means that you cannot, work with basic Excel files or basic database management systems. And that's why you have the concept of the relational database management system. Okay. So basically you transcending the file system method of storing data, of organizing data in organizations, the concept of the database management system came into play. And what's a database management system? It's a collection of programs that enables you to store, modify, and extract information from a database, right? Like I said earlier, a database simply is a unit that helps you to store and record data in your organization. And the purpose of me taking you through the concepts of an RDBMS is because as an analyst or as a data scientist, the bulk of your data is going to be stored in a database or in a relational database management system. And for that purpose, it is essential, it is very, very essential for you to understand how that database works. Because if you do not understand how that database works, it makes it difficult for you to relate with your primary data source. It makes it difficult for you to bring out data from that data source and use it to, create insights for your organization. To take us back a little bit, or let me just put it this way, I'm going to make this more emphatic, or more I'm going to actually break down the functions of a data analyst and the types of data analytics you have in our next class. For today, I'm going to just teach you through the RDBMS. So, like I said, a database management system is a computer program designed for the purpose of managing databases. Please pardon the spelling error there. I'm not that bad with English normally. Okay, so now the types of database management systems you have, there are actually four basic types of database management systems. So you have the hierarchical, you have the network, you have the relational database management systems, and then you have the object relational database management systems. For the purpose of this class, and for the purpose of your job as a data analyst or a data scientist, we're going to focus primarily initially on relational database management systems. Those are like the popular types of databases you have all over the world. You have organizations all over the world: Microsoft, Google, Oracle, IHS, MTN, Ikeja Electric, and so on, storing their data in relational database management systems. There are reasons why the relational database management system is the DBMS of choice, and I'm going to show you a few of those reasons in the next upcoming slides. Okay, let me give you a small teaser. So for some of us who started our data journey a little bit earlier, we were familiar with database management systems in the form of Oracle. I think I started out my career with Oracle, and initially it looked like a very, very humongous thing. And I think the reason why it looked humongous was because you were dealing with an unprecedented amount of data. I mean, the very first time I worked with a database, we were storing data in excess of that was like 10 terabytes. And then it looked like a big deal to me, because 10 terabytes in 2008, yeah, that was 2008. 10 terabytes in 2008 was a very big deal. I'm sure most of us have computers and memory cards that run into 1 terabyte right now, but I mean, imagine what 10 terabytes was back then. Today, 10 terabytes is very, very small. No, but I mean, what's 10 terabytes? Anyways, so RDBMS features. The RDBMS is the most popular database system, more popular than the hierarchical, the network, and the object relational. The RDBMS was developed by E.F. Cord in the early 1970s. The model is based on tables, rows, and columns, and the manipulation of data stored within. When we were going through our assignment review, we talked about the fact that a database management system, or an RDBMS, consists of tables, of records stored in tables, which consists of rows and columns. Now, with an RDBMS, like this name implies, relational, you have multiple tables in one container, right, that are connected to each other. They are related to each other. The first diagram you saw when you signed into this class was a very small example of what that connection looked like. We will still see that in the next few slides. A relational database is a collection of these tables. Okay, so the first commercial system was Multics in 1978. I don't even think Multics still exists. If it does, it's probably run down now, because there are bigger guys who are more serious with the business. Okay, so main feature: a single database can be spread across several tables. Now, for those of us who use Excel traditionally right now, because based on the survey I carried out, I saw that most of us use Excel as our primary tool so far. I'm sure you've noticed that with your Excel, you have one place where you have all your records stored, right? Maybe the little transactions that you are doing, or some of us even actually have databases in our organizations, but we don't work directly with the database. So what happens is that there's a web portal, or there's a portal somewhere, and then we go and select the data we want based on that portal, and then we extract that data into an Excel document, and then we start working on that data. it's like the convenient way for a lot of us, because in most cases we're working with data of maybe the last 2 days or one day, and which is not so much at the end of the day. I mean, you could be working on transactions from yesterday. For example, if you work in a bank and let's say your branch just recorded 500,000 transactions yesterday, it's something you can easily go to the web portal for, which is connected to your database, and then pull out that data and work on it in Excel. On the other hand, a database is like a collection of all of that data you want in one table and several other tables that are descriptive or related to that data you are pulling out from. Okay, we'll go into much of that later in detail. Examples of RDBMSs include Oracle, IBM's DB2, Sybase, MySQL, and Microsoft Access. There's one last one that I did not include here, which is also very popular. In fact, more popular than Microsoft Access. It's a Microsoft tool also. It's a Microsoft SQL Server. So Oracle is the most popular database all over the world. I'm very sure if you're in an enterprise environment, you have one way or the other come across Oracle before. I think they have the largest share. I don't know the exact percentage, but I think Oracle has the largest database share in the world, and the bulk of the internet runs on Oracle databases. IBM DB2 is also another popular one, but I think in terms of popularity, after Oracle database, Microsoft SQL Server seems to be the most popular. It used to be that MySQL was a free software, and it was the go-to tool for most people who were deploying web applications, right? But today, MySQL has been acquired by Oracle, and for those who want to run MySQL, you have to request a license from Oracle. It's a competitive approach by Oracle, because considering the fact that Oracle is expensive to deploy and MySQL was a free tool, they just acquired MySQL and made people pay a little bit of something for it. MySQL was a major challenge for Oracle, and that was why they acquired it. Microsoft Access is mostly used by smaller organizations. You have, for people who want to use Microsoft as their own relational database management system, it's Microsoft SQL Server that is used mostly. I will include that in the updates I'm going to make to this slide, to this PowerPoint presentation, and I'm going to share it on the Telegram group. Okay. So, what are the advantages of an RDBMS? I think I said a lot of those advantages earlier, but this is quite a lot, and I don't think I want to bore you with all of these stories. Increases the sharing of data and faster development of new applications, not necessarily your business as a data analyst. Supports a simple data structure, namely tables or relations. Yes, it is a very, very wise way of storing your data. It limits the redundancy or replication of data. Now, let me give you an example. Where we're talking about limiting redundancy or replication of data. For example, now you have this Excel table. Maybe I'm going to bring Excel into the foray here so that you can see a practical example of what I'm trying to say. Okay, so now this is Excel, right? Traditionally, you want to create data. In fact, let me copy a bit of what I have from my own organization. This is supposed to be confidential data, but for the sake of this class, I'm just going to share a snippet of it with you, right? Now, look at this. Let me zoom this in so that you probably have a better view of what this is. This is a typical Excel table, okay? And this is how, most people would have stored their data prior to now. Now, because of the fact that this is a user-generated table, which I generated myself, there's something here that indicates a duplicate index. Traditionally, if you are creating data in Excel, you are bound to make replications or duplicates. You are bound to record the same entry more than once, right? With a relational database management system, this is properly and conveniently avoided. What I have here now is basically outage records for a period of time, right? But I could also have this data copied here and pasted here. Excuse me, 1 minute. So I could, please, as we're going, I want this to be as interactive as possible. If there's anything you want to ask a question about, just drop it in the comment section, that live chat box. I will look through it and I'll give you an answer. We've said a lot, and I'll really like that you raise your questions as we go. Don't let's wait till the end of the class before we start asking questions, because we might, going back and forth might be a bit of a problem. So as you have your questions, as you see things that you're not comfortable with or you want more insights on, please just drop them on the live chat box. I will go through that and get back. Let's just review together. Now, in this case, now what I did was copy this thing and then, let me see, paste it here. Right now, this is automatically, there's something showing up here, a duplicate count that tells you that this data is appearing 3 times. Of course, I was able to do this because I made some modifications to the Excel document itself. Okay, but traditionally, a relational database management system will not allow this, because in a relational database management system, this would have been my primary key, right? And the primary key enforces that there are no duplicates. We will go back to that primary key in some of the next slides, but a primary key in an RDBMS will ensure that I do not make this mistake of duplicating my data, which is basically what is being said here. So it limits redundancy or replication of data as much as possible. Duplicating your entries are going to cause problems for you, and you do not want that to happen to you as much as possible. Okay, now better integrity, as data inconsistencies are avoided by storing data in one place. Of course, you have a more sensible data set, you have more sensible work, you have data that is stored appropriately in one location, basically. So you, as much as possible, you're avoiding inconsistencies by using an RDBMS. And one of the reasons why this is because an RDBMS kind of enforces you to stick within the line. It gives you a reason to actually stay within the confines of whatever it is that has been set for you. Now, it provides physical data independence, so users do not have to be aware of underlying objects. That's not really your business for now. It offers logical database independence. Data can be viewed in different ways by different users. Okay, so let me give you a practical example. So you log into your Gmail or your Yahoo Mail, right? And you can get to see records from your own email alone, right? The truth is, all of your data, all of your emails, all of your whatever it is that comes into your mailbox is stored in databases on Google servers if you're using a Gmail account, or databases on Yahoo servers if you're using a Yahoo account. If you're using like an Office 365 account for your office, it means that your emails are stored in a database in Microsoft servers and so on. Anyways, the beauty of an RDBMS is that anybody from anywhere can have access to the contents of an RDBMS without necessarily interfering with the next person. If I have data stored in an Excel file, for example, now, that data is as viable or as useful to only the person who is looking at it at that point in time. All right. If I have that Excel file open with me, until I am done with it and I share it with you, you do not have access to the data that is stored in that Excel file. With an RDBMS, on the other hand, you have access to that data from anywhere. Okay, anybody can plug into. Of course, some people will say, "Oh, why not with Office 365 and Microsoft Excel Online? If you share that file, anybody anywhere can actually have access to the contents." Yes, that is quite true. But Office 365 and Excel Online also are limited by the 5 megabytes rule, which means that you cannot do anything. You cannot open an Excel file beyond 5 megabytes in Microsoft Online. Okay, Microsoft Excel Online. So, and trust me, it's not even comparable. with what you can have access to with an RDBMS. Let me quickly run through this because this is just a lot of stories on RDBMSs. Expandability is relatively easy to achieve by adding new views of the data as they are required. Supports one-off queries using SQL or other appropriate language. The SQL we talked about in the reviews that we said is the structured query language that is used to query data in your RDBMS. That's like the de facto language for getting access to your records in your RDBMS. Let me give you a small drift. For every time if you use, for example, Spotify, right, or any other music playing platform, for every time you request a song, what you are doing is you are sending a query to the Spotify database to return a particular song, and then it plays it for you. For every time you run a Google search on google.com, what you're doing is basically sending a query to Google's databases to look for a particular record. Okay? That's the underlying method by which search boxes work. You have a database that houses all of that data, and then you have a query through the search box that is referencing that data and returning it back to you. Okay, better backup and recovery procedures. With RDBMSs, you have a very, very extended functionality where you can easily store and recover, back up your databases and recover them. The ability to handle efficiently simple data types, and then multiple users can access, which is not possible in DBMS. Of course, I didn't talk to you about basic database management systems because I don't feel anybody in 2020 will be interested in a database management in a simple DBMS. Okay. So far so good. I think what we've been able to, let me just do a bit of a recap on this. What we've been able to talk about so far is we've been able to talk about a DBMS, basically types of database management systems, which we're focusing basically on the relational database management systems. Please, if my voice is too fast or if there's anything you are not comfortable with, please just drop it in the comment box. Let's improve this session as much as possible. All right. It's the most popular, an RDBMS is the most popular database system. It is based on tables, rows, and columns. It's a relational database. It's a collection of these tables, and it can be spread across several tables. And these are the examples. The advantages, which we've quickly just brushed through. Now, what are the disadvantages of an RDBMS? RDBMS software is expensive. I think the cost of deploying Oracle for an enterprise is per license ranges to like almost $10,000 or less. But considering that you install Oracle in instances on several servers, by the time you juxtapose that cost, it's actually very expensive to deploy. Same thing goes with SQL Server. Microsoft Access is actually cheap to deploy. MySQL used to be the cheapest because it was just free. Like you could just pick it up the shelf and use it. But because of the way it is now, with Oracle being in charge of it, it's a little bit more expensive to deploy than it used to be. For you as a free user, you have a few limitations. Now, it requires skilled knowledge to implement. Of course, nothing good comes easy. I'm sure if you want to eat in let me run the basic examples. If you want to go to Shiro Lagos for lunch, I don't know how many of us have gone to Shiro Lagos before. Or you can't compare the amounts you spend in Shiro Lagos with what you'd spend in, maybe Debonia's Pizza, or which means the better it is, the more expensive it becomes. So, now it requires skilled knowledge. Sorry, so that's like talking about the cost basically. Complex software means expensive hardware. Expensive hardware in the sense that while you can deploy Excel on just one simple laptop in your room and use it, for a database you are deploying it on a server environment. Because you are trying to expand and play around storage size and storage space, it means that you are using more expensive equipment. You are using network attached storages, you are using storage area networks, you are using RAID configurations for your servers to expand your storage capabilities and so on. Okay, well, I hope one day I can really sing bars in church. I've not really tried it out, but thank you very much. I think I hear that from time to time. So, like I was saying, yeah, so certain applications are slower processing. Yes, that you don't need to bother yourself about that. Like I said, the reason why we're going through RDBMS here is just so that you have a basic understanding of how databases work and why you need that knowledge to work with your data analytics tools. What next? What next? More difficult to recover if data is lost. Now, well, so the reason, because of this reason, right, it's the same reason why with RDBMSs or relational database management systems, you have people who are responsible for administering that database. You call them database administrators. You have different tiers of DBAs, but that's their job basically. And it is their responsibility to ensure that whatever data is being stored in the RDBMS is constantly available and properly backed up. Yes. Okay, so I'm seeing the question. Can we use cloud infrastructure to eradicate the expensive hardware that may be required? So I'm going to digress a little bit so that we can just quickly answer this question. Yes, you can. At the same time, cloud does not really come cheap, right? Yes, I believe, for me, let me give you my own analogy for this. While it is practically senseless to actually deploy your own in-house IT infrastructure for your database, I also believe that the moving to the cloud does not come cheap, but moving to the cloud has its own benefits. Okay. No, Simeon, not virtual machines, basically. So the cloud is more or less like you have cloud service providers like Amazon, like Google Cloud Computing, like Microsoft Azure, that give you basically, so you pay them for not software as a service. So, well, it could be software as a service, it could be platform as a service, it could be infrastructure as a service. I'll elucidate on some of these things in subsequent classes, but it's more or less like you are eradicating your own in-house server setup, and then you're putting all your data, all your processes, all your systems on one of these platforms provided by one of these guys. GCP, Microsoft Azure, or Amazon Cloud Computing. Those are like the most popular guys. Okay. Adetayo Akinsoya, fine. We'll share these PowerPoint slides with you so that you can actually work with it. All the best in your exams tomorrow. Okay. I thought this class was going to be lasting for just 1 hour, but I think we've extended a little bit. So just to round, I want us to quickly run through this so that everybody can go back to their ways. Some people are going back to work tomorrow. But Ben, we will discuss this later, the issue of cloud infrastructure and everything. Yes, it's a more reasonable approach because you have your data, it improves data redundancy. You have multiple copies of your data in several places. So cloud is actually way, way, way better than housing your own infrastructure in-house. Okay, so like I said, for this top point where it says that more difficult to recover if data is lost, is the reason why most RDBMSs are backed up in several places. Okay, and then you have a lot of people using cloud as a better option because with cloud they back up your data in multiple instances in several servers across several geographies. So it's actually, at the end of the day, right? If you can deploy a cloud platform, it's a better way for you as an organization to store your data. It's difficult to represent hierarchies, difficult to represent complex data types. We will talk about that later. But for the complex data types, yes, because of, we're in a new world now where you have multiple types of data coming in. Back then, it used to be that most of the data you had was just in forms of text and basically in form of text. But now you have blob, like, oh God, okay, fine. I said I was going to include that. Basic large object and club and so on. We have files that are a bit beyond just text. But of course, most of these things are being engineered into the regular updates you have in database management systems nowadays. So, I don't think we need this difference between DBMS database. Data is stored in a single large table for a DBMS. Single record modification affects the whole database. In an RDBMS, your database is broken down into smaller pieces. The changes will not affect the entire database. Basic, that's true. Now, so this is like the bulk of what I asked most of us to read about because this is the part where it starts getting interesting for you as a data analyst, right? Data in an RDBMS is stored in tables. By the way, sorry guys, I don't know, how do you deal with this thing? For me, when I see RDBMS, I'm tempted to say an RDBMS, right? Because there's an if before the R, basically. But in a relational database management system, so anyways, that's just grammar. Data in the RDBMS is stored in tables. Each table consists of rows and columns like a traditional Excel table, right? You know that in your Excel tables, you have your data stored in rows and columns. And that's like traditional way you have Excel tables. Same thing you have with your database. Now, each column is an attribute that describes the data. Okay, so for in your tables, for example, I'm going to show you what that looks like later. But for each table you have, your table has a has column headers, right? So on those column headers are like what identify what is inside each column, right? So each column is an attribute that describes the data. So for example, you have this column for name, this column for dates of birth, this column for age, and so on. That each column is what identifies that data, is the attributes for that data in a row. Each row in a table is a unique record made of different attributes. So like I said earlier, while each column is an attribute in itself, each row is like a collection of columns, right? Each row in a table is a collection of columns, which is basically different attributes. Now, in our DBMS structure, a row is also known as a record or a tuple. Short assignment. Go and, well, of course, I'm sure you guys already did that, but you've not. I want us, all of us, to go and research on what a tuple is. A tuple is basically a mathematical item, but I want us to go research on what a tuple is in relation to. That's like assignment number 1. So basically, this is a pictorial relation of a database, right? You have, so for example, the container here is your database, and in that database, you have multiple tables, okay? Table 1, table 2, table 3. Each of these tables, in one way or the other, is connected to the next one. I'll show you a practical example of that. Now, this is your table structure in an RDBMS, okay? Your table structure basically is, like I said, yes, like an array of arrays, something like that. Exactly. I like that concept. Like an array of arrays. That's from Augustine Chuku. Okay. So thank you, Adobe, for putting this out. Assignment number 1, research on tuple. So everybody in this class currently, and the ones that are the prodigal children in the Telegram group that, did not do their initial assignments, or the ones who did it and are not here, or the ones who did not even do it and are not here currently. So basically, this is your assignments. I'll add extra assignments for you, but basically, the first thing I want you guys to do is just research on a tuple. We'll review that later. So this is basically your database structure with related tables. You have all these tables in it. Now, this is your table structure, right? A table is also called a relation. I didn't ask you earlier, but a table is also called a relation. A relation in the sense that, considering the way you have your database structured, and we said it's a conglomeration of multiple tables that are related. Of course, in one big family, you have, let's assume your database is like your family, right? You have all your siblings in that database. Each sibling is an individual table, basically, with their own, individual data and so on. But all of you are related one way or the other. The common denominator or the common relationship will probably be your DNA, which you share across, which you inherited from your parents, basically, right? So that's why a table is called a relation. Now, the structure of this is basically, you can see the column or the attributes, right? Which is basically each column defining or describing the data you have in each row. The tuple or the row. Hi, Somto Chuku. I don't know if you're just joining or you want to ask a question, but you can go ahead. So a table is called a relation. You have the tuple or the row, and then you have the column or the attributes. Now, one thing I want you to pay serious attention to is the primary key. A primary key in every table in a database is basically a unique identifier. All right? Let me go over that again. A primary key in a table in your database is a unique identifier. It is that primary key that identifies your data. It is what references the entire row in that table. Okay, so I would show you something else later, but the function of the primary key, if you remember when we were checking the advantages of a relational database management system, and we said that it prevents duplicate entries, right? The function of the primary key is to prevent duplicate entries. Okay, it's just like normally when you have your table and then you have your serial number, which basically identifies everything you have in that table. Your primary key is like your serial number, but the only difference is that that serial number basically identifies everything. Now, in most RDBMSs, you won't even use just serial number to be your unique identifier, because your serial number might not be consistent across all tables in your RDBMS. I will try and come back to that later. But so basically, this gives you an understanding of what that looks like. Okay. Now, table relationships. If we go back to this previous slide, right? Now, this is one table, okay? And you can see that the headers in this table are what? The customer ID, the customer name, and the status, okay? Although the next slide is not particularly the same thing with what is here, I will show you that what you have here basically is a diagrammatic representation of the relationship between tables. I took this snapshot from Power BI. If you've used Power BI before, you are familiar with Power BI. I think you would know what I'm talking about here right now. But basically, this is a diagrammatic representation of how your tables in your database are related. Okay, what you have here basically is a table showing you the column headers or the attribute headers for each table, right? In this place, you can see these back and forth arrows and links between these tables. If there's something you can identify briefly, it's the fact that your sales representative here also occurs in your sales rep table as sales representative. Okay, your product key here in your sales table also appears as product key in your product table. Okay, we said during the assessment review, we said something about whether or not you can use you can have multiple columns with the same name in a database. And we said yes, across the database you can have multiple columns with the same name, but in a single table you cannot have multiple columns with the same name. Okay, so the relationship you have here is between, in this case for example, is between the product key in the product table and the product key in the sales table. Okay, between your product table and your sales rep table, what links the two of them is the sales representative column here and the sales representative column here in the product table. Between your date table and your sales table, you have your date here being related to your date here, as your date in your sales table is related to your date in your date table. Okay, please, this concept is very, very, very important. And by the time we start dealing with data models in Excel, by the time we start dealing with Power BI, Microsoft Power BI as a tool itself, it is going to be very, very important, because you need to understand how relationships between tables work, and that would really, really help you in your analytics career. So, moving on. SQL, which was what I actually asked everybody to define in the assessments, is known as the structured query language. It's a query language, or it's a language, it's a simple programming language that is used for accessing data from your database, modifying data from your database, and updating data in your database. Now, as a data analyst, you might not really be so much concerned with database administration. You might not really have any business administering the database or updating the records in the database. It's really not your business. The database is simply your own repository for data. And the reason why SQL is going to be very, very, very important to you is because That's like the query language for you to request data from the database. Now, not to say that you don't have alternative ways of requesting data from your database, okay? But in some cases, the existing query systems might not really work well for you. And you, as the analyst, might determine or decide how you want your data to be extracted from the database for you to do your further analysis, okay? So it's a simple programming language for accessing and managing data in relational databases. It was developed by IBM in 1970, but today everybody uses SQL. In fact, if you are applying for a data analytics role in most organizations, in Nigeria and abroad, the very first thing they would ask you, or they will ask you to do, is to, one of the very first things they might ask of you. As if you are now applying for all those small data analytics jobs in all these small companies. But if you're applying for like a major data analytics job, they want to see your proficiency with the SQL, because they expect you to be able to write queries to fetch your own data from the database without necessarily relying on somebody to prepare that data for you. So I am going to run through just basics of SQL, what it is and what it's used for, but I'm not going to go into detail of SQL right now. Next slide says, so the concept of SQL, how SQL works basically is you as the user specifies a certain condition, right? An SQL line usually looks something like select star from, or select dash from dash, where dash is dash. I didn't write that out here, but I'm going to, okay, you know what I can do also? Let me have my notepad so that some of these things I am saying, I can actually jot them down for you, okay? Basically, this is the syntax of a basic SQL statement. Select, let's say, name, let me use lowercase, from table 1, where, let me see, region equals, okay, let's see, Enugu. Now, this is what a basic SQL statement looks like, okay? Select star from dash, where dash is dash. In fact, let me change region to lowercase. Now, if you notice, or if you've noticed, your the select from and where are like the ones I left in capital, and those are the keywords you use in SQL. The beauty of SQL, and the reason why it's very easy to learn as a language, is that SQL is basically English. All right, it's just very simple English, and it's one of the one of the easiest programming languages to learn in the world. And you will be needing to learn SQL. If you've learned SQL already, congratulations to you. If you have not, at some point, excuse me. Okay. I don't know if you are still there. If you have problems with the connection, please let me know. I'm getting an indication that the stream quality is poor right now. So please, if you are having problems with the connection, please let me know. Okay. Is anybody having any issues? Can you hear me well? If you're not hearing me well, please let me know. Okay. Okay, so I'm going to assume that we are all on the same page, and maybe YouTube is lying to me, I guess. Anyways, so since I'm not really getting any response from this, okay, loud and clear, crystal clear. Okay, thank you very much. So, like I was saying, I mean, these people are liars. It's clear. Can you imagine? And they are telling me that they are not receiving enough video to maintain smooth streaming. Okay, so that's fine. Thank you everybody for the feedback. Thank you. So now, SQL, like I said, is a very simple language to learn. It's very easy to learn, and I'll start sharing materials with you for SQL, but I want us to take it step by step. Why I'm bringing in SQL right now in the concepts of the RDBMS is because SQL is that language, that primary language you use to communicate with your database. And like I said earlier, as a data analyst, it is going to be required of you to be able to query records from the database without nobody actually giving you that data you need to work with on the fly. Okay? So basically, when you specify your condition, like you saw in the small statement I wrote, select name from table one, where region is this. Okay, this is basically a very straightforward SQL statement. And what happens is when you click submit, this guy goes into the database. It will go through all the records in that database file and select the records that satisfy the condition. So basically, it's more or less like when you use an if statement, or okay, visuals are not sharp for real, audio is perfect. That's a bit surprising. Why? Okay, let me check back on my streaming software. That's a bit surprising. I don't know why exactly, but and at 30 frames per second, this is going a bit smoothly. But while you can hear me, how bad is the video, please? Can you see what's currently on the screen? Concepts of SQL, user specifies a certain condition. The program will go through all the records in the database file and select those records that satisfy this condition. That is what is presently showing on my screen. Okay, Otaro Gane, thank you very much. Okay, so let's just quickly rush through this. We've spent more than 1 hour in this class. Although it's not been as interactive as I expected or I wanted it to be, I believe subsequent classes will be more interactive. So basically, your SQL goes through that. Your SQL statement goes through the database and looks for every matching condition and then returns it to you. Okay, the result of the query will then be returned in form of a table. So basically, you have the SQL frame. Okay. Sorry, hold on, please. So I'm using an extra monitor so that you can see me. This is actually plugged onto my laptop, but I sincere apologies for that. Okay. Visuals and audio are top notch on this end. Try changing to 360p. Okay. Well, I think because I have started this already, I don't think I can change the streaming settings again. Okay. So well. Okay, 1 minute. I don't know if it is still possible. Let me see if I can change this. Okay, well. For now, you can put up posts to make it more interactive next time. Okay, fine. I will try that. Thank you for all the feedback. I think no, I can't. Okay. Chimo Hassan, no, you can't. What exactly? Like you can't see the video or you can't hear the audio. Changing the viewer. Oh, okay. All right. Okay, thank you, Sonta. Now I understand. Okay, so for you, if you're viewing on your own end, okay, thank you, Otorogan. Like he said, like Somto has said, you can change your your streaming settings from maybe if you're probably streaming on 1080, you can change to like 360p, so that you have it consumes less data, and in case your internet connection is not so fast, it's a lot better for you. Okay. All right. Thank you, guys. Thank you very much. I like the interactivity in this class, and it's going to really be a spur for me going forward. Okay. So let's continue while everyone sorts out their internet and streaming settings. So user specifies a certain condition, blah blah blah. The program goes through all the records in the database and selects those records that satisfy the condition. Sometimes when you're trying to pick data from an Excel file, okay, like what you have here, what you usually do is you have a filter, right? And then let's say you want to see all records. Let me use this place for example. You want to see all records from region North 1, okay, where the priority is P2. Okay, this is basically what you do with filters, right? But with, okay, oh, thank you very much, Bode Oluyede. Thank you very much. I try as much as possible to break things down. And please, if at any point in time you're not comfortable, or you're not finding what I'm doing sexy or sweet enough, please just always bring it up to my notice. We can always change the approach. Okay, so basically, what I've done right now is to filter these records based on two criteria, right? The region here and the site priority here. Okay, if you were to do this in a database, you would have written an SQL statement, right, to return this for you. And your SQL statement will look more or less like select, let's say, star from, let's call this database book, this database table book 1, right, where your region, let me see, let me try and follow the exact syntax you have here. Region IPT is equal to so, let's say north 2, right? And let's say site priority equals to, in fact, I'm supposed to use single quotes for this, equals to, oh shoot, equals to P1. Okay, I think we chose P2 the other time. Okay. I'm just giving you samples of an SQL statement. Okay. While I used a filter to narrow down this guy to just north 2 and priority 1, or let's say priority 2. Okay. Okay, sorry, let me modify this statement. It's not properly written. Okay. Sharif Akinlolu, how do I change to 360p? So at the bottom of your video, you're probably going to see something that looks like HD settings. I can't really remember exactly what it looks like, but let me see from my own screen. You see that settings button. Okay, so you see a settings button, and then you can click on quality. I think auto is supposed to be at 360p. But in case you are streaming at, let's say, 480p, you can reduce it to 360. If you're on 360 and you're not really okay with what you're seeing, if it's a mobile phone you're viewing from, you can change it to 240p. Okay. If you're viewing it from a computer, when you change it to 240p, you might want to adjust your screen settings so that you can see it properly. Okay. So let me continue with this. So, like I said, you can write a small statement in SQL. I mean, an SQL statement that runs through your database and returns this record for you. And so when it's returning the records for you, it returns it in this format, okay, as a table, giving back to you like this. All right. Let me go back. So the result of the query will be returned in form of a table. Beautiful. Which is what we just saw. Okay. Wow. I did not. Okay, fine. For the sake of this review that we've just done, I'm very sorry that I did not complete this presentation very well. It was supposed to be completed better than this, but I think I did not do that very well. Anyways, I'm going to run through a few things that I did not talk about here, which I promised I was going to talk about. So let me change the format of this to something larger and legible that we can all see. Okay, now with your database, okay, with your DBMS or your relational database management system, so there's one thing I want to emphasize which I did not talk about in that slide, and I'm going to also include it in what I'm sharing with you when I update the slides. Okay, a lot of us are familiar with, we use Excel to store our data, okay? And there's one thing with Excel. Excel is very flexible when it comes to how you can store your data, okay? You can have a column in Excel that allows you to keep both numbers and text and anything in one column. Okay, but with your relational database management system, there's a bit of constraint to data types. Now, let me explain what that means. It means that in an RDBMS, if this column contains, let me delete this, please. If this column contains numbers, right? As long as you have set the data type here to be number, everything here has to be a number. You cannot put text here and expect it to work properly. No. It's going to throw back an error for you, a data type error. If you have chosen this column to be variable character, now that's varchar. It's like a data type in database management systems. We call it varchar. It's variable character. Variable character means that string or that column can contain any type of data. It could be text only, it could be numbers only, it could be anything. It could be a mixture of text and numbers, but it could be anything, right? So with a database in an RDBMS, data types are kind of strictly enforced. So I'm going to go back to this place and I'm going to say this. So with relational database management systems, data types are very, very important. Very, very important. Okay. Let me give you the list of data types you have. Basically, your data type would either be, for some of us who have done a bit of programming before, you will probably be able to deal with this. It could be a text. It could be your data in your column could be a number. Now, number is basically a little bit large. Your number could be float, which is decimals. Your number could be integer, which is whole numbers. Now, what this means basically is if you have a column that is supposed to contain float decimals and you type in a whole number, for example 2, what is represented in that column will be 2.0, which is the decimal version of it. If you have a column that is supposed to be integer, right, whole number, if you have a column which is supposed to be integer whole number and you throw in a decimal, okay, Augustine, it is not advised. In fact, you don't use more than one primary key in one table. Okay, one table, one primary key. Multiple tables, multiple primary keys. Okay, in the other, so your primary key in that table is basically your unique identifier. All right, for that table, whatever it is you have in that table, whatever you choose to make your primary key. So let me give you an example. So let me just quickly run through this question. So you have a record of, you have a data. Let me come here and use Excel for this. So you have this table of let's say employees in an organization, right? You have their name, or let me say you have first name, last name, yeah. Let me say address, and you have what's the last thing? Let me see something else. Let me give you something else. Let's say age. Okay, or let me even say state of origin. Now, you know it is possible for me to have, okay, let me insert the serial number also. So let's just make this look like a normal table. Serial number 1, 2, 3, 4, right? And let's say the first person's name is I'm going to use the names I'm seeing here. Olukunle Abiodun, right? Olukunle Abiodun. Permit me, guys. I have Jimo Hassan. Okay. I have Oyebode Oloyede. And I have Josh Dari. Oh, sorry. I was supposed to change something here. This is not supposed to be like this. Now, let's assume state of origin. You guys could have come from Oyo, Oshun, and Ondo. And don't mind me, I know this is not where people came from, particularly. And if my guess is right, well, thank you very much. Maybe you owe me a biscuit or something for getting this right. This is the controversial one. Age 23, 24. Who is 234? 23, 25, right? Now, with this table, this is basically what your average table looks like in an RDBMS. Okay, you have, so this is basically a record or a row or a tuple. This is a column or an attribute. Okay. Now, it is possible that tomorrow we employ another person. I'm sure Jim or Hassan, I'm very sure that you know very well that you are not the only person in the whole of Nigeria bearing this name, Jim or Hassan. A random search on Facebook will tell you that probably there are more than one Jim or Hassans. In fact, all the name combinations I can see here, I'm very sure there are more than one of them all over Nigeria. Okay, and for that reason, it is expedient that if tomorrow this organization employs somebody else whose name is Olukunle Abiodun, right? Let's assume that this Olukunle Abiodun is from Ondo State, okay? And he's also 23. Basically, what has happened here is we have Olukunle Abiodun duplicated in these two columns, right? And the age here is 23, the age here is 23. However, the distinguishing factor here is their state of origin. One Olukunle Abiodun is from Oyo State. The other Olukunle Abiodun is from Ondo State. Okay? To avoid the confusions that might arise from identifying Olukunle Abiodun in subsequent data requests is the reason why you need a primary key or a unique identifier. Okay? In most tables, your primary key is your unique key, and that's your unique identifier. And one extra column can be added here, which is called the employee ID. Okay? So, for example, we're bringing in Olukunle Abiodun, who is from Oyo State. We identify him as, let's say, EMP001, right? That's employee number 1. And as we're bringing in new people, we identify them as employee number 2, employee number 3, employee number 4, employee number 5. Now, why it is not suggested or advised to use your serial number as a unique identifier is because your serial numbers might vary across tables, and it's not really, if for example I'm trying to relate with the employees in my organization, I can't call somebody number 1 or number 2. But if I'm asking you for your employee ID and you give me EMP001, for example, it's an easier way to identify you. Now, this is one table, okay? And this is your primary key, okay? This is your primary key, and this is what ensures that you don't have duplicates. A serial number can be automatically generated for every record. Same thing goes for your primary key, can be automatically generated for every record. But it is essential that you note that this guy cannot be duplicated. So if I want to make reference to the Olukunle Abiodun who is from Oyo State and is 23 years old, in fact, let me add one more column so that, let's say department, okay? Exactly, yes. Does this mean the BVN acts like a unique identifier in the databases of financial institutions? So I think one of the reasons why they came up with the BVN structure was to unify your records across banks, okay? You can go to Bank A today. In fact, when the data harmonization system started in banks, the very first thing they did was to come up with the new bank account number, okay? That's your 10-digit account number, which is basically peculiar to everybody wherever you are across your banks. But because you can leave Bank A, right? You've committed a bit of fraud or whatever, or you've borrowed money from Fidelity Bank and you've refused to return their money. So you abandon that bank account and then you go to, let's say, Zenith Bank, and say you want to open another account. The BVN acts like a unique identifier that identifies you across all banks, okay? So yes, a BVN is like a unique identifier, and it's like a primary key in every. So the beauty of BVN right now is even that it doesn't stop at banks alone. It cuts across all financial institutions. You probably want to take a loan, they would ask you for your BVN. You want to take insurance, they'll probably ask you for your BVN so that they can see you. Yeah. Okay, so something like this also, you ask to leave a middle name. Yes, and even at that, sometimes even after you've left your middle name, it is possible that there are more than one person who has your exact 3-name combination. Okay, so and that's why something like your BVN or the employee ID is very, very essential. Okay, I am going to try and round up this class tonight. I can see a lot of people are already leaving. People have to go to work tomorrow. I'll try and continue this from where we stopped tonight, tomorrow. In the meantime, by tomorrow morning, I'm going to share with you a more comprehensive slide that contains a few of the things I have talked about tonight that were not in the original slide. Okay. But let me quickly round up this. Okay. Like I said, data types are very, very important in your relational database management systems, right? And while you have text, number, I was making one reference here where I said that your each column in a database has, so if you look at this very well, this is basically text, this is text, this is text, this is number, this is not text, this is variable character, varchar. Okay, and let me list that out as amongst the varchar. So under number you have float, you have integer. In fact, you have I'm not going to go into the extra ones for now. You have long number, you have exponential values, scientific representation of numbers like exponent, I mean 10.0 times 10 raised to the power 12, or 1.0 exponential 12, and so on. Now, you could have date types. Okay, you could have in fact, and your date type could have dates, just dates alone. You could have date and time. Okay, you could have, then you have time also as another data type, and so on. So anyhow, it is just important to note that in every database you have, these things are practically enforced. If a database table has text as the content of that column, then it means throughout you have to enforce text as the content of that column. Okay, if it has numbers as the content of that column, it means that throughout that column you should have numbers, and so on and so forth. I'll be rounding up now. I'm going to try and improve the delivery next time. This was like our first time. In fact, this is the first time I'm taking an online class. I've not really done it before. I think I do better with one-on-one interactions when I'm seeing everybody face to face, and we can crack jokes and all. But going forward, I'm going to try and make this a little bit more interactive, a little bit more better. More better. Anyhow, there's nothing like there's nothing like more better. I'm going to try and make this a little bit better going forward. Okay, and I hope that the next classes will be a lot better. I will share with you a topic to read on between today and tomorrow. I'm going to have to like start preparing for work tomorrow now, and I have a few reports to close in on. But as a final note, okay, I want to show you what a database would probably look like. And this is not really a database, don't get me wrong, but I just want to show you what it will look like to have multiple tables in a database. This is Power BI, right? And if you are seeing this now, it will probably give you an understanding of why I had to take you through it will give you an understanding of why I had to take you through RDBMS concepts. Basically, Power BI, Tableau, which are like the most popular data analytics tools and data visualization tools, run with a setup that looks like a database management system. Okay, and like I said, here shows you how those tables are related, and this is like the content of each table. In fact, I can also show you what the data type enforcement looks like. Okay, by editing query, I can show you this guy. Hold on, please. Okay, fine. I think I deleted these tables, so you probably won't see them here. Okay, let's ignore this for now. I think I'll open another one some other time and show you what the data type enforcement looks like. But look at this now. You see this place, right? These are the different data types you could have had in this database table or whatever. Decimal number, fixed decimal, whole number, percentage, date, time, time zone, duration, text, true, false, binary, and so on. Okay. In the next class, I'm going to show you a practical DBMS, RDBMS, which is MySQL. I'm going to run an instance for you, and I'll show you how you could have much more data types. For tonight, thank you everyone who showed up. Thank you for managing my delivery. Ben, thank you very much. I appreciate the compliments. I really appreciate that. And thanks for, gingering me up. I'll try and make this class a lot better next time. So, thank you to everybody that participated. Have a wonderful night rest. If you have any questions, please ask them before I disappear from this stream. Now, okay? For those who are still online, this is basically, in fact, this dashboard was created by one of the students in this class who has been asking me for a bit of mentorship. We were doing like one-on-one mentorship before. This was a sample dashboard created by her. I will share with you, and that's why I decided to show you guys this, because it's from it's where you can get to. This is very, very, like a beginner thing, and I think you guys can actually do better with it. Okay. Thank you very much, everybody. I really appreciate the compliments. Thank you very, very much. Next class will be better. I'll try and be more prepared and have a lot more data for you guys to work with. Till the next time we see, we will continue our conversations on the Telegram group. Have a wonderful night, everybody. The next class will not be tomorrow. It will probably be on Thursday. But I'll communicate duly with you when the next class will be. All right? Thank you very much, everyone. Have a wonderful night rest. We shall continue our conversations on the Telegram group. All right. You are making my head swell. In fact, thank you to thank you very much. Thank you, everybody. I know I was supposed to have left off, but and hopefully I get to know everybody one on one. By the way, that's one thing I didn't even talk about. I was supposed to open some people's yash here because going through the results on the test, I think practically a lot of people scored well, like 5/8. I think 5/8 was the least score, but it could be better. All right. Good night, everyone. Good night, everybody. Thank you very much. I'm ending the stream now. Bye.